So I'd like to call for the next talk, which is student involvement in PI-led mission operations, and it'll be given by Bill Possel.
One of the things I'd like to mention is that there's a lot of history that I'm not going to cover today. Randy Davis is here, who was here for many years before I was. I arrived in 2006, and we did a seminar a couple weeks ago now that Tom Mason in the EPO office has recorded, that had the people that closest started this program, and talked about the history of the mission ops that we've done at LASP. So I'm going to pretty much focus on what we're doing today. One of the things that I've heard attributed to Charlie is something where he said that don't ask if something is too hard to do. Just start doing it, and by the time you're halfway done, you won't realize that it was hard to do. I think that's an expression that we continue to do at LASP, where we don't look at things as being too hard. We just go do them. This button?
No, that doesn't work. Use one of the arrow keys.
The arrow keys.
Sorry.
So I'm going to be talking about mission ops at LASP. This was a cartoon out of the Daily Camera a couple years ago. And boy, is it accurate. So here we are at a university operating spacecraft. My background is before I got to LASP, I was in the Air Force, and I did spacecraft operations with highly paid people, 24/7, sitting around, doing really hard stuff. And when I came to LASP, actually for a tour, it was like, wow, what are you doing? You're doing ops with students? This is part of the legacy, I think, from Charlie when we started doing the SME program, where we brought in students to do what people had thought was impossible for students to do, and that's operate spacecraft. So this was a cartoon probably out of the either AIM days when we talked about operating AIM from here, but as people are getting to know us, it's amazing the amount of interest that we have in the student part of our operations, where the media come banging on the door saying, hey, what's going on at LASP? Can we interview some students, especially the ops students? You've seen this before. Obviously, we have a long history of spacecraft instruments, space instruments, and operating instruments and spacecraft. The history of the ops goes back into the OGO days, and then into Mariner, and then the first one being SME, where this program, the foundation of what I'm going to describe, was laid out. And again, I think if you watch this video, it's a tremendous video. It has Tom put together, with Karen's help, a bunch of the pictures of facilities and people, and there is a picture of the ops room in the warehouse, 55th Street, so yes, you can do ops in a warehouse. I love this one. I think some of these are from Randy. So Mariner 8 ops, you can see some of the fancy hardware that we use. I believe on SME we were the first ones to use colored CRTs. So that was really impressive. On the right, MMS. So we launched that a couple months ago now. 4 spacecraft, magnetospheric multi-scale mission, 4 spacecraft, 100 instruments that LASP will be operating from here. So it is, it goes back to, yes, we can do the very hard. And again, you have a professional and a student sitting next to each other doing the mission. Part of this comes from what we have developed here at LASP, and that's the synergism that comes with this integrated science, having the engineering in the same facility, having the calibration and test facilities, doing the ops and the data systems all in one place. A student can come here and pretty much see the whole thing. We have had ops students involved in integration and test. We've had ops students involved in software, the whole aspect, the data analysis. It's an amazing opportunity for students to see end-to-end how we do science. Specifically in the mission ops and data systems area, our group is the ones where we developed the concepts for operating a spacecraft. We try to get pulled in as early as we can with the development of the spacecraft, development of ops concepts. We bring in, we have existing systems that we're operating. I'll talk more about that. But we have people that also do the data analysis and data processing and the ops software. So yes, the ops students get a lot of attention because they're the ones sending the commands to spacecraft and instruments. But there's a lot of other student opportunities, a lot of other students that are involved in the background in getting the ops software ready, getting the processing data, working hand in glove with the scientists to get that data out. There's students involved in all aspects of that, and they have the same model where they're sitting side by side with a professional staff member of LASP and getting that mentorship that will make them a better engineer, scientist when they graduate. We've been doing this for 34 years. These are the missions we've been doing. SME, the STRV that we did in the 90s, Snowy, talked about that one. QuickScat, and from then on, we've been doing QuickScat since 1999. That one's actually going to be deorbited. The mission's pretty much over. The instrument's pretty much on its last legs. We'll be deorbiting that one in November timeframe. So the current missions, I mentioned QuickScat, SOURCE, AIM, and Kepler. Kepler is always an interesting one because it's certainly easy to explain that to the public. It's easy to explain that to the students, to the parents of students. You're looking for planets. That one just recently has its mission extended to a different type of mission in the sense that it's has 4 reaction wheels. 2 of them have failed. We've come up with a unique way to use solar pressure to help point the spacecraft to the area that you want to study, and we've got the mission extended to 2017 now based on that new concept. I've mentioned this before, but we do a lot of things on the ops side to the spacecraft that were never imagined when the spacecraft designers put this together. We're doing SOURCE now with very limited battery support. We basically put it into safe mode during the eclipse time, bring it back out of safe mode, turn the instruments on when you're in the sun, and we're doing this completely autonomously. Again, something that was not planned. AIM, you've probably heard of the challenges we've had with AIM. That is another one that, the people that came up with the concept of how you can continue AIM when you can't get a command into it the normal way, that'll be written about when we're done with the AIM mission. We're not giving away all our secrets on that one. We don't want anybody to kind of copy that or try to do anything facetious or bad with that, but it's another tale where the ops people have come up with such creative things to do to keep these missions going and to keep that science going. Instruments, we've been doing instruments for a long time. The current ones, we're supporting MAVEN, EVE, Cassini, New Horizons, going to Pluto, and then, as I mentioned, MMS. So we've gone from, before we were handling 12 to 14 instruments from LASP, MMS has now taken that to 100. So quite the jump in our capability. So we do this with students, and this is something that was started with Charlie. The integrated team of students and staff members, and you kind of ask yourself, how do you do that? How do you bring in, especially undergrad students, and get them to work in an operations environment and basically send commands to spacecraft that are hundreds of millions of dollars? And I'll talk a little bit more about that. If you're familiar with us, the students are the ones that their command console is the one that's set up to actually send the commands. So every command, besides the autonomous ones, for example, the first commands that went to Kepler was a student operator that sent that command. And you think back, this is a 19-year-old, 18, 19, 20, not old enough to drink, which is good. Barely voting. Let's not go there. We are very strict. But they're the ones that sent that first command to Kepler. Put that on your resume and see what reaction you get. That person's working at JPL right now. So, but it's an interesting concept. All the students, the commands comes from the students. We currently have about 20 students working in ops. This varies depending on the number of missions we have and how busy we are. We range graduate and undergraduate. Most of them are undergraduate. The graduate ones are ones that started as an undergrad, have been promoted, they're staying for their master's, and we put them more in charge of student groups. They're there for all aspects of the mission. We pull them in when missions are in development. We pull them in for planning and scheduling. They do the real-time commanding. One of the interesting aspects is they're looking at plots every day from the telemetry that comes from the spacecraft and trying to help us understand trends that are going on. We have an automated system that if there's something really wrong with the spacecraft, we get paged. If there's something trending in the wrong direction, we expect students to catch that. They are the ones looking at plots every day from the telemetry systems, and their students are divided into subsystems like battery, thermal, communication, and they have a team that's looking at each spacecraft, each instrument that we operate here, and they're the ones that are telling us, there's something wrong with this squiggly line. It doesn't quite look right. And they're the ones that bring that to our attention. Again, with staff members helping them. We also pull them in for anomalies. It's interesting. Their schedule is, when we bring them in, we pretty much tell them, your time is ours. Yes, we'll let you go to school, class. The rest of the time is ours. So we give them time to go to class, but the rest of the time they're on either shift or kind of on standby. So if they're here, they're going to be doing work. If they're on standby, if we have an anomaly, which happens with older spacecraft, we pull them in and they get firsthand experience what it's like to work a spacecraft problem. And they only happen at nights, weekends, holidays, student birthdays. Yes. We're starting a new class in a couple weeks. We did the interviewing and hiring. I believe we had over 100 resumes for about 10 positions this past year. One thing which I really like is that we don't specify what degree you're in. It doesn't have to be aerospace engineering. So we have science majors, we have all sorts of engineering majors. My understanding is we've had a film major go through this program before. The thing we ask is that you have a love for doing this kind of work, love for space missions, and a dedication and a willingness to come in at middle of the night on your birthdays, on the holidays, and do this kind of work. We go through a 10-week training program. It's a very intense program. It's 8 hours a day. These are paid positions. I forgot to mention that earlier. These are paid positions, so they're getting paid at this point to learn. So if you're a business person and you're looking at the business model for this, I'm losing money. We're losing money on the brand new students. They get more experience the first year. They're still learning. That second year, they're starting to be more productive. By the third year, they're superstars. They're doing the same work that a staff member would be doing, and they're just barely getting a little bit more than, $12, $15 an hour with no benefits. And I'm getting the same work out of them that I do out of professionals, pretty much. What a deal for NASA! What a deal for your tax dollars! And we continue to get tremendous value out of these missions. The training is intense. It's classroom lectures, then we move on to hands-on training where you're on console, and then and you're shadowing the senior command controllers, the seniors who are around, and we have a lot of exams they have to pass. Yeah, so mostly engineering, but we'll take any major, start them at the sophomore year. We'd like to have them at least 1 year. We do have a few freshmen that apply, but we try to get them to learn what it's like to be a college student first before you start working here, because it is so intense. We ask them to work 20 hours a week during the school year. And again, as I mentioned, those hours could be middle of the night, weekends, depending on when we need you to send commands or to support other work. And then 40 hours in the summer. In this training program, though, we give them everything, the basics of aerospace engineering. We teach them, the thermal, command and data handling. So any major, again, you don't have to be the aerospace engineer to be an ops person. We'll train you. We have a lot of, obviously, the real-time training is an important part of it. Teaching them how the data goes, the process we use for that, how to be on console. That is, there's a protocol with communicating with people that are on the console, repeating a command, what to do if you're getting an instruction from the professional sitting next to you to do something, and you're saying, hey, that doesn't make sense. What do you do? How do you tell your professional, well, you're making a mistake here, buddy? So we teach them how to do that, and they are allowed to tell us that. You're screwing up. We appreciate that. So we go through what it's like, real-time operations. They go through subsystems. And just as an aside, here's a picture of some of our students who graduated a couple years ago. And I just noticed this yesterday. JPL, Northrop Grumman, Lockheed, Raytheon. The individual with the glasses closest to you was part of the Curiosity mission that landed on Mars. It's an amazing, all of them graduated successfully, but they were all part of our student team. 3 exams they have to pass, written exams, they have oral exams. We do lose 30 to 40% of the students through this process. Some can't hack it. Some get to school and realize, hey, this is a job, and I've got schoolwork, and we lose a few there. But once they're settled in, they learn time management. They are amazing. They are an integral part of how we do things. And then after graduation, it's the word's getting out more and more about LASP and this program, where I'm getting phone calls saying, hey, do you have any folks? Can I talk to your folks? JPL's one that hires quite a few of our folks. They have a recruiter, a technical person that comes 2-3 times a year to twist arms. She's kind of funny because I had one student that was Northrop Grumman or JPL, and when she selected Northrop Grumman, this person at JPL was just furious at me. It was like, it's not my fault, but she's doing well. And now all these other companies, and yes, as we mentioned before, we do keep a few at LASP. My preference is that they go out in the big world and see what else is out there and then come back to LASP. We've had that. But otherwise, it's a tremendous program that we have. Again, thanks to Dr. Barth and his vision in putting this together. And it really has made a very hard problem now look pretty easy. So with that, if you have any questions?
So Gary, say your name first.
This is Gary Thomas. I've been here a long time, but I noticed this one check on that we only built one spacecraft here. Now, what's the reason for that? Maybe Randy knows the answer to that, or
We'd like a more functional federal government, then we build a lot more of them. But we have built small, like CubeSats and stuff now, and we're back on the path of building a spacecraft that's going to go to Mars, for example. So Snowy launched a whole set of ideas that we've had, and I think we're going to continue to move in that direction.
Questions, comments?
Yes.
Hi, from University of Colorado. I'm sorry if I missed at the beginning. How many students have worked with mission ops over the years, would you say?
Can you repeat the question?
So how many students have worked through the mission ops? I don't have an exact number, but I would say hundreds.
I was going to say 200 was a rough.
Probably
estimate.
200. I know when we did, at SME and Snowy, we had large groups.
Yes, SME alone, we probably hit almost 100 by the time we were done. And so, I'd say well over 200. I would
Yes,
guess.
over 200.
Fran
Yeah.
Bagnall.
How many in this room came through this program?
Yes, we have a few that have gone through this. I know this is hearsay for scientists, but and I won't quote his name, but one scientist came to me and said, if I knew this program was here as an undergrad, I wouldn't be a scientist today.
Yes.
Jeremy Winnick. I used to work at AFRL, and I had some side things about there used to be programs in the Air Force, Department of Defense, Space Test Program, and such things.
Yeah.
And they would often give you the satellite, say we'll support it for 9 months or a year, and questions came up, if it's still working, could we find someone else to operate it? And I knew I was always on the edge of these things, but negotiations, do you negotiate with people who maybe want you to take over?
We have talked about that. Is there still value in the instruments on board? Is there, especially if it's a science mission, we prefer the science missions. But
if it's sort of restricted data, they probably just complicated.
yeah, if it's classified data, we tend not to want to do that here. But
So the one case where we really did that, there were 2 satellites that were built by the Defense Research Agency of the United Kingdom, which is essentially roughly like DARPA or something here. And they had used them for about a year and were satisfied with their results and were ready to give them up. But folks at JPL had been using the spacecraft for some communications experiments and wanted to continue. And so they asked us if we would take over the operation of those 2 spacecraft. And we did do that. We went over to England and to Farnborough and learned how to do that. And then over a 3-month period, we literally transferred the operation from Farnborough to Boulder. Essentially, first of all, they operated and we watched. and then we watched and they operated. We operated and they watched, and then we just, at the end of the 3-month period, we took over and ran them for several years. One thing about that was that they actually deeded, in essence, the spacecraft to the university, and when that happened, the university PR folks picked it up and it appeared in the papers. And the day after that, I got a call from the lawyers and saying, we now are responsible for these spacecraft. What if they fall out of orbit on somebody's house? You know? So the good news was they were in orbit where they weren't going to come down for 29,000 years. So right after that, I told him he was off the hook.
Do we still own them now?
You know, we probably still own them.
Oh, no. I'll be retired by then.
28,000 and, you know, some years to go yet, but if they come back down on somebody's house, we could be in trouble.
Yeah.
Other questions, comments? Okay, thanks, Bill.
Okay.